Are our hypothetical models wrong, or is it the universe? Well, the response is clear. The James Webb Telescope has now recorded an entire series of baffling revelations that go against ordinary cosmology. What progressive information can be gathered from these inconceivable designs? Are our suppositions about the age or nature of the universe still reasonable, or do we now have to concede that we have been on the wrong cosmic track for quite some time? The investigation of the universe is subject to constant change, and this change has led to many intriguing developments in the past. Consider the perspective of our distant ancestors, who were firmly convinced that the Earth was the center of the universe around which all other celestial bodies rotated. Today, of course, we realize that our planet is just a tiny piece of a vast, intricate cosmic picture that we have yet to fully understand. It seems that every new discovery must overcome a few internal obstacles. Need a model? Although Edwin Hubble had recognized that almost all observed galaxies were moving away from us, Albert Einstein clung tightly to his image of a rigid, static universe. He added the cosmological constant to his field equation to align with this perspective. Looking back, we can say that Einstein later acknowledged his error, calling it the greatest mistake of his life. Hubble's observations of galaxy movement were linked to the relentless expansion of the universe, a process we now believe began not yesterday but around 13.8 billion years ago with the Big Bang. Contrary to initial assumptions, however, this process did not depict a massive explosion into existing space. Rather, it was the rapid expansion of space itself from a singularity. Matter, time, and space all emerged from this small, hot starting point. But how do we know this today? We look backward, observing the corresponding evolution of cosmic phenomena. This enables us to calculate back to a point where the density of matter and energy becomes infinite and all spatial distances converge to zero. Another substantial proof of the Big Bang theory is the observation of cosmic microwave background radiation. This remnant from the time shortly after the universe's creation is almost isotropic and fills the entire universe. It's been widely accepted as evidence, but what about discoveries that cannot be reconciled with the Big Bang theory and the findings based on it? The cosmological consensus is that the first stars formed 200 to 300 million years after the Big Bang and that the first galaxies were still galactic dwarfs. After all, there wasn't enough ordinary matter to form full-blown galactic giants, or so we thought. Yet last year, the James Webb Telescope detected something that, strictly speaking, shouldn't exist: impossible galaxies. Astrophysicist Ivo Lab and his team at Swinburne University of Technology in Melbourne analyzed images from the Near-Infrared Camera, NIRCam, in the early release program of the James Webb Telescope. The images showed a portion of the sky near the Big Dipper, known for containing some of the earliest stars and galaxies. It didn't take long for Lab to realize that he and his colleagues had identified something remarkable. He described the initial reaction to this groundbreaking discovery as follows: I run the analysis software, and it spits out two numbers: distance, 13.1 billion years, and mass, 100 billion stars. I almost spilled my coffee. I knew we had just discovered the impossible, impossibly early, impossibly massive galaxies. Here's why the term impossible was used. For these galaxies to exist, either the density of matter in the young universe would have to have been 2 to 3 times greater than our models suggest, or the galaxies must have formed in a manner totally unknown to us. Either way, scientists are now facing a major conundrum. Both cases require a significant revision in our understanding of the universe. So far, scientists have failed to provide a clear explanation for this unexpected discovery. What is certain is that, 500 to 700 million years after the Big Bang, there were already 6 galaxies with 10 billion, and, in one case, even 100 billion, solar masses of stars, comparable to the Milky Way today. Considering this, it's unsurprising that the research group has dubbed these objects universe breakers. This discovery calls into question what was previously thought to be scientifically certain. The mass of stars in this stage of the universe is up to 100 times greater than the old models suggest. Until now, cosmology has assumed that galaxies begin as small clouds of stars and dust that gradually grow larger. But is it impossible that this is not the only way galaxies form? This discovery only deepens the mystery that scientists now face. Yet another recent discovery by the James Webb Telescope emphasizes the importance of unraveling this enigma. The $10 billion device recently identified a new record holder for the earliest known galaxy, JWST 140, observed by scientists at Scuola Normale Superiore in Pisa. The data indicates that this gravitationally bound collection of stars formed 290 million years after the universe's birth. And it likely took around 100 million years to grow to its observed size. Interestingly, this is not the faint baby galaxy predicted by current models. Instead, it's a structure with several hundred million solar masses of stars. Once again, the question arises, how could such a brilliant and massive galaxy have emerged so soon in the universe's history? Further investigation shows that the galaxy contains not only hydrogen but also emission lines of oxygen, suggesting that multiple massive generations of stars had already completed their life cycles before this galaxy was observed. Questions continue to mount, but are there any answers? Given these revelations, some might think that each new discovery by the James Webb Telescope only deepens the crisis for cosmologists. But fortunately, the answers are also emerging. Roughly 380,000 years after the Big Bang, during the so-called Dark Ages, there were no galaxies, stars, or light sources. The universe was filled with dense darkness and neutral hydrogen gas. About 100 million years later, the so-called reionization process began, in which hydrogen became ionized and transparent again. A process made possible by the first highly energetic stars that knocked electrons out of hydrogen atoms. The early universe come from? This question has been debated for decades. Some theories propose the role of black holes, but the James Webb Telescope has now lifted the cosmic veil and revealed a glimpse behind the scenes of light production. An international research team has found that small dwarf galaxies indeed produced vast amounts of high-energy radiation. Researchers identified these galaxies as part of the CEERS, Cosmic Evolution Early Release Science, program, which uses the Webb's NIRSpec and NIRCam instruments. Observing the illumination of distant galaxies sometimes requires a clever trick, known as the gravitational lens effect, where light is bent by massive objects in space, allowing the telescope to capture distant, faint galaxies that would otherwise be invisible. Spectroscopic analysis showed that these small galaxies emit more radiation than previously believed, about 3 times more. As a result, astronomers are now confident that they have finally found the elusive photon sources that once reionized the universe. This discovery indicates that these low-mass galaxies collectively altered the state of the entire universe during its early stages. Our understanding of the universe continues to evolve, and discoveries from the James Webb Telescope may continue to challenge, refine, and even transform cosmology as we know it.